Okay, morning. This video is part of the scientific programming lecture at the University of Bremen, and we would like in this session to continue our project development. The last session we started to develop a new project using the Spider editor, and before we really start this project we would like to have a look at a very important tool which we would continuously use during our development. That's the so-called version control system, the Git version control system. We will again basically looking at the same slides. So basically it's lecture 6, and as always you can download it from the same address. And we are going now to the second part of this lecture, basically starting from page 11, which is or page 12, which has to do with the project management. And as you remember, just in the last video we were creating a projects folder, and within a linsolver project which contains at the moment some files, basically some solvers.py which will contain our solvers, and testsolvers.py which contains our test routines for the solvers, and some directories which were creating by the Spider development environment. Now, before to start to develop, it's very important that we are able to track the history of our developments. And you would ask, you can also ask why. I mean, what's the problem? I'm just developing, and if I'm ready and I'm finished, and I have the program. But you have to think about that this development goes over weeks and weeks, even our lecture, just step by step. And the typical scenario during the development is that you are developing a feature, you are testing a feature, and it seems to work quite nicely. And then you are basically extending this feature or creating also a new feature. And at some point maybe realize that something which worked before doesn't work anymore. So basically it doesn't give the correct numerical result anymore in our case, or it doesn't behave as it should be. And then the big question is, what can you do? And the nice thing is that if you keep the basically the history of your project, so time to time you are making a photo of your project, of the state of the project, and you keep that, then basically you can go back in history to the last point where it's still where this feature which doesn't work anymore still worked, and then find the first point where basically it ceased to work. And then the only thing that changes you have to investigate is between these two states, because basically going from one state to the other was the step which broke that feature. And that's very handy, because especially if you determine the failure of the feature quite late, so basically you have already developed a lot since you first time implemented this feature, the code maybe changed a lot, then in a big code maybe you would have to look up over millions of lines. While if you have kept the history, then you have to concentrate on this one single change which broke it, the first change which broke it, and maybe that contains only a few lines or a few tenths of lines. So basically not that much, and it's much easier to find the mistake. In order to do that, we will use the Git version control system. We will see that Git is also very helpful for other scenarios, like for example coordinating the development between developers. So basically if many people or more than one person is working on a project, then it's very important that you can work in parallel, and Git helps to orchestrate that, and we will see later that it's very helpful. And basically all open source projects which are publicly running, almost all of them uses also Git version controlling system. So this is a very important thing to learn for us. Okay. Let us have a look basically here. So basically I told you what Git is. Maybe one quick word about what kind of version control systems we have. Basically there are two groups, the so-called centralized and distributed one. Centralized means that you need a central server to access the history of the project, and decentralized or distributed in a very simple, expressing it in a very simple way, means that basically you have the entire history on your laptop, on your computer. So even if you are sitting in a plane, a transatlantic flight, and basically you are programming and you want to go back to history, you don't have to connect to a server, you don't need any internet, you have basically the entire version history within also. So everybody who has the project has the entire version history. And basically nowadays predominantly, especially in the open source area, it's a distributed Git version control system is the one which is used. So this is why we will learn also that one. In order to start with Git, it's very important that you have basically set up Git correctly. Especially, basically every photo you make will be tagged by your name and by your email, and therefore you have basically here to configure Git by setting your username and your user email, so that basically the changes you make can be associated with you. So basically you would say git config and the -- global, which means it should be valid for all your projects, and then basically user.name, and that's my name. Here you should write, of course, your name. Then I would like to set my email here. So basically you should set your email, because that will also pop up in the log messages. So basically, which we will do when we make a photo, we will always make a message to that. Exactly. And then there are a few settings, so that's the bare minimum. And there are a few settings which you should also, I would recommend you to do, is to basically set up the editor, the diff tool. We will see it is there in order to compare different versions of the code, and the merge tool. At the moment we will not use it, but later we will use it if we want to bring back different versions of the code, maybe developed by different people on different machines. Then this merge tool we will use kdiff free. So basically I would suggest you to set up those things here. Actually, if you want to copy paste it, you can double click with the left mouse button. Then you click here with the left mouse button, and the middle mouse button you are just inserting it. So basically under Unix you don't even need Ctrl+C and Ctrl+V for copy paste. That works also with the left and the middle mouse button. Basically these config options are actually stored, as always under Unix, is usually stored in a file, and this file is basically in your home directory, and it's called git config. And if you see here, this git config contains exactly those things which I was entering. So you could, in theory, also, if you know what the format is and what to write there, you can even modify it with leafpad if you wish. So that there's nothing special, just a simple text file. Also, there's also git. There's a for the config. There's an option -- list, and then you can have also a few. For Git, it's very typical that you have always the command git and the so-called sub command. So basically, you always start all the git commands with git, and then there is a sub command you specify, and then various options for the sub command. So this is a very common pattern. Now, the first thing we have to do is we have to tell Git that we would like to have a so-called repository. A repository is a directory with eventual subdirectories which contains our project. And in order to do so, we will just make git init. And by the way, maybe you realized I was here just doing in or ini and then pushing the tab button. So basically here the expansion, automatic expansion, works also for the git subcommands. So if you write in and you push the tab button twice, it shows you that you can have init instaweb on interpret trailers as command. We want to use the init command. And basically git init in the current directory means that this directory should be put under git control. If you look what happened, on the first glance nothing happened, but if we are here listing also the hidden files, that we see that there was a directory created, the .git directory. This .git directory contains everything which Git knows about our project. This is very nice. Because if you copy the entire linsolver directory, for example, you put it into an archive and send it somebody, or you are just copying from one machine to the other, as long as you also copy the subdirectories, this .git directory, all the version history and everything what Git knows about this project will travel with it. So basically, all the information is placed in the same directory, and that's quite nice. What you definitely should not do is basically fool around in the .git directory. So basically that's configured by Git, and that's managed by Git. And there are some special cases where you can have some config files there which you can change, but usually it's better, unless you exactly know what you do, it's better to stay outside of the .git directory. I mean, if you look at that, you see that it has some further subdirectories and so on and so on. So the internal structure is not really relevant for us. The only thing it's important, if you have a .git directory, it contains everything about the project in that directory. If you delete the .git directory, by the way, so if you basically say rs.git, then you would basically clean all the history and everything Git knows about that. So it's better not to do it. So be careful with that. Now, basically, we would like to introduce Git, the files which we would like put under version control. What does it mean? We would like to tell Git which are the files from for which we want to keep the history recorded. And for us, that would be the solvers.py and the testsolvers.py files. So basically, we say git add solvers.p and testsolvers.p. And then Git didn't respond anything, which is already a good sign. That means that probably it was successful. And if you now add the git status command, which asks Git, okay, what is the current status? Then we get something like this. We are on the branch master. That's at the moment is not important. We will work for the moment always on the branch master. Later we will learn what it is. We have not committed anything, so we didn't make any pictures yet from our project. We didn't store any pictures from our project. It even tells how the changes can be committed, so how I could make the first snapshot of my project. And it says that if I would make it such a snapshot, such a commit, then there would be a new file solvers.p and the new file testsolvers.p. And then there are two files which are sort of untracked, so Git doesn't know what to do about them. There is this .spy project, which is even a hidden file, and this PyCache thing, _PyCache. And if you make an ls, indeed we have this .spy project and this PyCache. Those things are, however, something which do not have directly to do with our project. This has to do with the editor which we are using for the project. And if you think about maybe somebody else wants to work on your projects, he is using a completely different editor. So basically he won't necessarily need your editor settings, and therefore I would suggest not to include those files into the, not to put those files under version control. However, it's very annoying if Git is always complaining about this untracked file, and therefore we will tell Git to ignore those files when we are when looking for changes and files. And that we will do by opening in this directory, creating a new file which is called git ignore, and this is the file which Git contains all the files which Git should ignore. And then here we add the .spy project and this PyCache file. Actually, this PyCache is not created by the editor, it's created by Python in order to speed up execution, but that's not relevant. The only thing is this is not something we would like to include. And if we now make git status, and actually I can here also use the expansion by tab, then the picture is a little bit different. The new files are still the same, but the two files basically they're vanished, but there is no the .git ignore file, which is of course also something which could be put under version control, and that's also something which I recommend and usually is put under version control. So we are saying git add .git ignore, and then st doesn't work. This is an abbreviation which we will use later, but at the moment it doesn't work yet. But if you do git status, then you see that basically here we have added three new files, the .git ignore, the solvers.py and the testsolvers.py to our project. And then basically the next thing we would like to do is to check it in, and you can check it in by using the git commit command. So basically commit means make a snapshot now, and let's do that. We are saying git commit, and then it pops up an editor which is the leafpad editor. In our environment you can configure it to something else if you wish, and here we have to say something about the commit, and basically I can just say okay, initial commit of project files. So basically here this is absolutely up to you what you write as a text, but the usual convention is you are writing one line of very short description what this snapshot does. So basically what changed since the last snapshot, or because if it's the first one, what it is supposed to do. If you want to add some more description, then you would make an empty line and then some more verbose description here. But the first one, we will see also why it should be short and compact, but nevertheless describe the changes as close as possible. And we will just save it with Ctrl S and leave it with Ctrl Q. And then basically it says, okay, here initial commit of project files and free files changed. So basically those free files had been added. Fine. So basically we made a snapshot. How do we know that this snapshot exists? We can just have a look at git log. That's the next subcommand which we want to have a look at. Log is being shown on the log messages. And you see here, I, the author, this is my name, which I configured on this date, was basically making a commit, a snapshot with the log message initial commit of project files. And this is exactly what we will do. We will basically step by step making snapshots of our project. Whenever we develop something, we will make a snapshot so that we can all go back in time if it's necessary, or look how the development was done. And then for all of the snapshots, we will get such an entry in the log. And you see that here, this horrible long number, identifies actually your snapshot. This is a unique number, a so-called hash number, which is unique for your snapshot. And basically, if you want to say, I want to do something with this state of the code, then you have to enter this number. Fortunately, not the entire number. It's enough to enter the first few digits, as long as it is unique, so it's clear which one you meant. Also, very often you don't need this entire information. You just want to have something short. So git log, and then I can just say I use the option -1 line. Again, with the tab, I can expand it, and then you get a very short description of that. And then and this is exactly why it's important to have a short commit message in the first line, because then if your commit message is something like 60 characters wide, then it can be very nicely shown on screen without line break if you get the one-liner log of Git. So this is the reason why you should have a very short line. Okay, now let's create something else. Let's add one more new file to the project. So we will just here change to the Spider editor, for example, or we can just also do it with Leafpad. I will do it with Leafpad. So we will just create a README file. That is something all projects should have. And this README file, let's say the name of our stuff is linsolver. I don't know, there are different ways how we can mark, we will see, or linsolvers actually. That's the name of the package, and I just say package containing routines for solving linear system of equations, for example. I'm just Ctrl S, I'm saving Ctrl Q, I'm leaving Leafpad, and you see exactly, no, there's also a README file. And then if we are asking for git status, it says nothing. Basically the old files didn't change, but we have no README. And now we can basically try again. How does it work? How can I make Git aware that it should track this file? We would just say git add. We would like to add the file README. And now if we do status, oops, yeah, I should use the expansion. That's much better. Then the chance is smaller that I'm mistyping something. Then you see that basically the changes would be, if I would commit, the changes which would be committed is that there is a new file README and its content would be committed. So we are doing that. Git commit, what is the log message? Adding README file. Right, I mean, this is very descriptive, and this is exactly what we did. So I'm adding the README file, and then basically we have it. And if you now have a look at git log, let's say -1 line, then you see that basically we have here two commits: the first commit, the initial commits, and the second commit. And it's very usual that basically you get the history backwards. So basically the last entries are shown first, which is usually the case, because usually think of that if you have a project with thousands or 10,000s of commits, usually you want to have a look at the last one, the last few ones, and not the very one which was committed 20 years ago, right? And also if you make just git log, it's the same, then you get this more verbose information in reverse order. If the number of entries is so big that basically it would fill up your screen already, so it's bigger than the size of your screen. So basically, if I make git log, then you see that it shows the first one, and then it waits, and then this is a pager, and with space I can just jump up and down, or with back I can go back. So basically I can just, or page up, page down, I can here go up and down in the history, and with Q I can leave it. So Git is intelligent enough to start a pager immediately if the log messages are longer than your screen is. But if they are not longer, then it shows all of them. Okay, good. So this is how we can check history. Now let's have a look one more how things work in Git, in the Git workflow. So basically we had the Git config where you introduce yourself, and the Git init to set up the repository of your project. This config, you do it once for your account. The Git init, you do it once for every project, and then basically in the project files you are editing the files, you are adding them with git add, and then you are basically you are with git commit, you are here committing them, right? So you have git add and git commit. Now let's have a look what would happen if we would just change one of the files. And now I will restart Spider3 because I would like to change one of the source files. So why not doing it in the editor, which we just get known in the previous session. And basically it shouldn't take too long until Spider starts, and you see Spider basically opens automatically the last project which we worked at. And let's assume we are changing something in the solvers.p. I don't know, we can just here just enter a new line. It's not really relevant at the moment, and I'm just saving it with Ctrl S. And if we are now changing here to the git, and we are asking git status, then it says that okay, the solvers.py has been modified. Now if we just try to make a commit to record that change, nothing happens, because Git does not record anything automatically. You have to tell Git explicitly what to record. So basically what you would do is you would say git add again, although this is not a new file, Git knows about that already. Nevertheless, you would make git add solvers.py. Okay, and now let's have a look what happens now. Git status, and it say okay, at the next commit, if you make a commit, then basically there would be a modified file solvers.py, and that means it would record that modification. And then if I would make git commit now, then basically it would store that with that content. What you should be aware of is that if you change after you have made this git add means nothing else that you are putting the file in the status, exactly in the status as it was at the moment of the git add command. It would be put in a so-called stage, and then with git commit, the content of the stage is written to the repository. However, you could change the file in your working directory even farther. So basically, we could just add some silly comment, which is not that necessary here, but returning the result. And this is exactly a way of comment you should never do, because you should never comment on something which is trivial anyway. So I'm just doing it to demonstrate here the effect. And now if you do git status, you see that there are two different things. First of all, if you would make a commit, then there would be a modified solvers.py, but this is the stage which the file had when we executed git add the last time. However, since that there were some other changes, and those changes won't be in the records. So if I want to add also those changes, I can also say git add solvers.py again, and then now if I make git status, then it would update the status of the file on the stage. So basically on the stage, and the file on the stage or in the stage area and in your working directory are exactly the same, and that would be then recorded. And there is also another way how you can achieve that you are adding everything which has been changed, and Git knows about that. Again, it's that, and you can say git add and -u, which means basically add all the files which has been updated, which has been changed with respect to their status in the database. And then you don't have to write the file names one by one, especially if you have many. It's a little bit more complicated, but it would add add all of them, and then if we have a look at git status, now we could basically submit it. What happens if you do not want to submit it? You say, oh, okay, by my modification, I just made up my mind, I don't want to submit them. Then how can I remove this from the staging area? And this exactly tells it here. It says git reset head, and the name of the file would remove it from the stage area, so unstage it. So basically, if I'm making git reset head and the name of the file solvers.p, and now I'm making a git status, then you see that it's not in the staged area anymore. Basically here it would be under the changes not staged for the commit, so I would be back to the original version. On my disk is still changed, but git would not record that change yet. And again, if you make up your mind with git add solvers.p or git add -u, you could add it. However, the changes which we made were quite ridiculous, and especially we don't want to keep them. And the next question is, how can I then undo my changes? So basically revert solvers.py to the state how it was last time recorded with a commit. So basically, how can I make sure that I'm throwing away all the changes from solvers.p and going back to the last recorded stage? And this is actually a scenario which happens more often than you think. Sometimes you're starting to code up something, you are changing many files, and after 3 hours you realize that nothing works at all. Your program is completely ruined, and basically you have not the slightest idea of what you messed up, and the only thing you wish to do is start from scratch again and do it step by step. And then it's very helpful to say, okay, let's go back to the last recorded state. And that you can do by basically checking out a given file, git check out. I mean, it tells you also here. Here says git add would update the file so that it can be committed, or alternatively, git check out would discard any changes in a working directory. So that means if I'm making git check out, the double dash and the name of the file solvers.py, then it will immediately read out the last state of solvers.p which has been recorded and override solvers.p by that. And you see in the working directory in solvers.p, I have this ridiculous command and this new line. I don't need any of them. So let's see whether that happens. I'm here basically checking it out. And if you have a look now at solvers.p, you see that there disappeared. So what happens here? Basically here the editor didn't realize it yet, but if I'm reloading this file, I just have to find it where to reload. It's usually usually it recognizes automatically anyway. Okay, there is no menu for that, but basically very often it realizes automatically. So basically, if you wait long enough, that happens automatically. Otherwise, basically, there is also, I searched the right position, but it was not the right name. It's the revert function. So the revert would basically revert file from this. That means it would reload it and convert back to the one which is on this. So just basically, if you change the files via Git, make sure that you are reloading them here in Spider. But basically the point which I wanted to demonstrate that basically with the help of git checkout, you can basically overwrite a given file with the last version which is stored in the repository, and that's very often a very useful feature. A few notes on Git, especially here, for example, the question is when you should make a commit, how often you should make a commit, and basically that's a sort of, you have to find out yourself, but it's very important that you should not make a commit after every line of change, of course, because then it's not very useful. But it's also not very useful if you are coding up 2,000 lines and then make a commit, because basically somebody who is looking at your project should be able to understand the steps between the commits. Okay, so basically based on going from one commit to the other, it should be easy to see what you were changing. And especially you should always make a commit if you made a small self-contained change and then basically make a snapshot. Very important that you should have a very nice log message to do so. Otherwise, log messages can be otherwise very useless. So as we discussed, this typical scenario here, the log messages. Just let me show you. I will just close the browser because sometimes it doesn't open the links from the PDF the first time. And interesting enough, if I start the browser and then try to click the link, then sometimes it works. And don't ask me why. This is something I also don't understand myself yet. But if you start the browser and then click the link, then it works. And basically, this is a very, very nice page which details how to write a git commit message. And I would really suggest you and strongly recommend you to follow the things here. And as you see here in this XKCD comic, so basically, if your git history looks like this, and those are the comic log messages, then basically at some point it doesn't make any sense at all, right? So it's very important to write proper git messages. And one possibility is one format which also this site allows is this short description followed by an empty line and a long description, and so on and so on. And one final note: if you want to write a log message and a log message is just one line, then you can prevent Git to open an editor, but basically pass this message basically here with the -m option. Okay. Of course, Git can follow everything which you can do with your project. So for example, if you want to rename things, like I want to rename the readme files in something else, let's say in readme.txt, what does it mean? Then I would say git move. So, but not move, but you have git move, so that make sure that Git gets aware of that. And I'm just renaming readme in readme. Let's say txt. And then if I execute it, there is no error message, so probably it has been successfully executed. And you see now the file is called readme.txt. And if I'm asking git status, then you see that basically yes, Git really got aware of that. But of course, this is also a change in our repository, and this change is not recorded yet. We would have to record it in order to store it in the history. So I can say git commit, and then now I'm passing the log message, and I'm saying, okay, git commit -m renamed readme, or add suffix to readme file, right? And we know that we were extending the readme file with a suffix, and then now if I make git log, we see that it pops up in the history. And now the file is renamed. But of course, the file is only renamed in this snapshot, right? Not in the old snapshots. And this is also something which is very handy. Let's assume I want to go back to history, for example, to this snapshot. So basically go back one snapshot in history. Then I will just select those few characters here from this hash sum. That should be long enough to be unique. And now if I'm saying git and check out, and that's the next command, check out means give me a committed version, check out, and then now I'm inserting this string here, these characters here. Then basically I'm going back to version. It says also I'm going back to the version blah 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 blah, which was here, had the log message adding a readme file. And if you look at here, you again have the readme file. So basically just renaming the file means from the point when you rename the file, up from that point upwards in history, it will have the new name. But if you go back in history to old versions, then of course the file will have its old name, and of course also the old content. So basically the snapshots which you make from your project, they are permanent. They are keeping the project in that stage always. If you go back to that. Now let's go back to the master branch, so the beginning at the end of our history. And now if you look, we are back to the end of our history with the last commit, which added just a suffix. Okay. It works the same with the rm. If you want to basically remove an unnecessary file which you just for some reason added to the repository, I won't demonstrate that, but it's exactly the same thing. You have to make a git rm, then the file is deleted, and also Git will be aware of that. But of course, again, you have to commit it, the change, in order for Git to keep it in the database in the history. And again, deleting a file only means that the file is deleted from that point of on history. If you go back to previous commits, then it will be still there. And therefore, please be careful not to check in Git something which is sensitive or has any passwords or some information you don't want to have, because git rm would delete it, but it won't delete it from the history. Okay, so it's always affect only future revisions. Now let's make a change. I would like to make a change here. Let's open the file, the readme.txt, for example, and I would like to change something, for example, this marker to something else. We will later see what those markers are, so let's don't care about that for the moment. Just I made a change, and this is also a very helpful function of Git. Sometimes it's a good question, what did I change since the last commit? So basically, typical scenario, your program doesn't work, you want to see what you changed in the last few hours, then you can say git diff, and git diff would you show you a difference. Basically it says the readme.txt file changed, and basically minus means a line which has been removed, plus means a line which has been added, and basically the line with the stars has been removed and the line with the hash marks has been added. Then there's a line which is unchanged because it has no sign in the front of, and then minus plus again, and it shows a little bit a few more lines so that you see the context. Of course, this diff is nice, but it could be nicer if you would see the two files next to each other, and that you can reach with the git diff tool command, which again shows a diff, but basically a file based in a graphical environment. And it asks for every file whether you want to see the diff or not. If you just hit enter, it will show you the diff. And we configured Git to use the kdiff tool, which is in my opinion one of the best tools you can have for comparing files. And you see here the two files next to each other with all lines. That's a nice thing. And then you see, okay, here the line is marked with yellow, which means this was something which was changed. And you see, or here is also marked, which means here the stars had been exchanged to hash marks, and also stars here to hash marks. So it's very nice. You can see graphically the two files next to each other, and basically all the changes record. There are also other tools which you can use for comparing graphically, not just kdiff. So if you have another tool which you like more, you can also configure Git to use that instead of kdiff. The main thing is that you have something with which you can graphically compare files, because it makes your life definitely much easier during development. Okay, now let's check in the changes which we had. So basically the changes are quite minor. It's just changing the marker, but let's have a look. And then I say git commit and then -m changing markers. Again, this is a change which is a very micro change, so maybe it's not worth to check in. But basically it didn't do. Why? Because I didn't add it. So basically nothing was staged. But now if I say git add -u and now I'm committing, then it should work, and indeed the file has been checked in. And if you are looking at git log, there is a new revision, or if I'm making log and one line, then you see that there's a new revision here. So we have learned before how to compare the status of your working directory with the last recorded version of your project, but of course you can compare also states between different commits, and the syntax is quite similar, git diff or git diff tool, depending which one you prefer, the text or the graphical one, and then you give the first commit. Let's say the first commit should be this one. So this is where we're starting from, so in the stage of the file in this commit, compared to the stage of the file in this commit, right? So basically we could just make between them, and of course now I will just deliberately choose the last commit and the one before that. So basically the change is exactly as we have seen before, but of course you can go also farther back to the history, and you can compare any point of history which you recorded with any point of history. So that works everything all fine. One thing which is also interesting, if you have a git log and one line, of course you can track down the history of the files that we have seen, that we can go back with git checkout to a given status of the project. So for example, if I wanted to go back here in history to this release, to this commit, then I could just say git checkout and this commit. And then important thing is Git tells you are in a so-called detached head state. I won't discuss in detail what it is. You can read about that a little bit if you like. But the thing which the take-home message for today would be, here you should not commit any changes. So if you went back to history, you cannot change history. Okay, that's usually not possible with the usual Git with the tools which I'm showing you, and also you should not do that. You can just visit the changes here. So for example, if this one, for example, this commit was the first one in the history which broke something, so which has a bug, you can investigate here what is the bug, find the bug, but then you have to go back. The best thing is you go back to the head, to the last stage of your project, which you can basically say by checking out, check out, and master. So master basically is the top of your branch, the last one on your master branch, and if you check out this, then basically the head position, so where you are is not the top of master, and you see this is exactly the last commit which was adding the readme file. So this is exactly the way how you can move around in history. Okay, so this is exactly what we did, and we had a look about all for all those things which are described here. Previous commits can be checked out. Yes, what will be very useful for us in the future if you would set at some git aliases, because as you had seen, we have to type git commands quite a lot, and even if you find a tool which can do everything graphically, I would suggest you to use the command line interface for a while until you get familiar with git and the git commands. But it would be good to spare a little bit of typing, and we would just I would suggest you to invoke some aliases. So for example, we could use the alias CI instead of commit. Similarly, I want to have CO for the checkout, which is must. Then ST, you have seen me typing that already unintentionally. Then diff tool is a very long word, and then usually I prefer to use just gdiff, like graphical diff, instead of diff tool. And maybe one possibility here, it's a short log, an S log, which is a kind of getting a prettified log here. I set it globally, so basically they will be stored in the global git config file. So basically if you open in your home directory, not the config but the git config file, then you see that basically those aliases have been written here, so you could also edit them here, as doesn't make any difference. Everything is text file for the git configuration. And the nice thing is now I can mix git status for git instead of git status, or git checkout, and then some of the revision, or as we had before with the diff tool, right, where we were just using it, then I could write just git gdiff whatever, and then it's much shorter. And basically from now on in the lectures I will use those things, so please be aware that when you use the when you see the slides, the abbreviations, then I assume that you basically executed those config command once, and of course you have to execute it once for your account, because they are stored in the git config file in your account, and that's much faster than to use. Then one last thing I would like to mention and discuss with you is tagging versions. I mean, you see that for example, let's make git log, which is now this short log. That's a very nice and short log, giving the date and the commit the hash mark, and this one line from the commit message. But of course, typing those things is not very nice, right? And especially if you have some special versions, like for example the release. You reach a stage where you want to release your code, and you want to make sure that you always know that this version was the one which was released officially as version, let's say 0.0. Then you can use the so-called tags, the so-called annotated tags, and if you don't write anything, just tag -a and here a string, then basically it will use this name, in this case the string 0.1, to describe or to name this commit, the last commit in the history. If you want to name another commit, then you could write here a commit number here, like 5e whatever, for example, if you do not mean the last one. But if you just do it this way, then it will mean the last one. And here is an annotated thing, so basically you can also enter a log message here and just saying, okay, I will just say tagging tag version 0.1. Okay, I'm saving it, I'm quitting it. And if you do not git slog, you see that it's the same as before, but here a tag appears at that commit which has the name 0.1. Why is that so useful? Because from now on, if you mean that commit, you can also use this short abbreviated name. So for example, you can say whatever, if you want to, you can git gdiff between let's say some ancient version and version 0.1, then basically you will get exactly what we expect. So basically, these tags you can use in order to abbreviate commits, and you should give tags for every commit which has some very big importance for your project. Typically, you are tagging releases. So when you have a release, a stable release which you give to the public, then you tag it so that you can make sure you can go back every time you want. Because if this is the version which you're distributing, maybe in the meantime you are still developing your project and proceeding, and then some user says, yeah, but I have found a bug in version 0.1, and then you start to think, oh gosh, which was the version 0.1, which commit was this? But if you have a tag instead, then you can say, okay, no problem, then I will just check out version tag version 0.1, and then you get exactly the state of the project which the user basically complains about that. So basically those tags are descriptive names for certain commits. If you want to have some help on a Git command, then of course you can use git help, and for example commit, then you get the man page and the manual page with all the things which the Git commit can do or accepts as an option. There are a lot. And what is also very useful are graphical Git clients. At the beginning, I really suggest not to use them in order to execute Git commands, because you should use the command line. But it's very nice to investigate Git history. And one possibility you can use is Git K. It's a very simple one, and that's a nice thing is here you see the history in a graphical projection, and you see this is where we started and this is where we are, and you also see this is a tag 0.1, and this is exactly also at the end of the master branch. So basically this is where the pointer, the master branch pointer points to, and you can basically click on the individual releases, and then you see basically what kind of files were changing, but and you see also the log messages. So basically you can a quick overview over what happened, and even if you want to look at the individual files here in the basically here in the patch, you see the diffs in a text form, but you can also select which file you want to investigate. And of course this was the first release. Basically the diff was that we were adding all these files, so before there was nothing, and now we had the full file. But if you, for example, looking at this one where we says changing markers, then you see again the same screen as we said before in the text mode. So it's very nice, and especially here this part, this graphical overview over the history is very nice. And later we will have also branches, so basically histories with some branching point and merging back, then it's even more valuable to have a graphical comparison and a graphical view of that. So this is what Git K is for. Okay, and yes, basically that's almost everything. The last thing I would like to show you is how to clone a repository. Cloning a repository means you are getting somebody's repository, right? So if somebody is hosting somewhere a Git repository, you can just download it and use it as if it were yours. So basically you get all the development history, and you can work in that repository as it were yours. And one possibility, for example, I have uploaded here the lin solver repository, which contains the solution for the lin solver project, and that you can clone by basically writing git clone and the URL which where the repository is contained. And let's try this one. Of course, before we do that, we are going out from this for all lin solver project, and I will just say let's say a folder making solution, and I'm just going in there, and now I'm just cloning it. The problem is, of course, it didn't work out because here the string was broken in two parts. So basically this supposed to be one single string, but basically let's just here insert it one by one. This is a long URL. How can you know that? I will show you that in a second. How can you know that? You can basically know this URL by going to the BCCMS website where the slides are, and you know that basically the URL you find always at the beginning of the slides. So basically if you go exactly to the same place where you were downloading the slides, then here at 6 here there's the Git URL, and this is exactly this URL here which I just entered, and that we can clone now. So let's have a look what happens if we clone it. And it's cloning into lint solver. So basically that means it created a folder lint solver. If you go to a lint solver, you see there are a lot of things there. And now let's have a look with git k on that, so the graphical git client, and you see that now here this is basically the final stage of the state of the project. You even see that sometimes there's something funny with the history. This is some points we will cover very soon, and making branches, which is very, very helpful if you are working with 2 persons on that. And basically here you see there are the commits, and I'm tagging always the stage, which is the stage at the end of the given exercise. So basically, if you want to look up the solution for exercise 6, so basically how the project should look like at the end of when you solve exercise 6, then you have to go back in history in this git repository and check out exercise 6, which is a tag for a given exercise. Either you could enter this horrible commit ID, or you're just using the tag name. So basically, if you wanted to have a look, how I think would be one possible solution at the beginning, at the end of exercise 6, then basically I can say git check out, or even better CO, because I have no this abbreviation, and then I say which tag, exercise, and you see the tabulation, the tab works again, exercise 06, and then I'm checking it out, and then basically here I'm at this commit where I implemented the basic Gaussian elimination algorithm, and now you see that the project is much simpler as before. It contains only 3 files, right? So basically that way you can go back in history in the solution which I give, and go back to the exercise which you are interested in. And of course you can always also with git diff have a look what changed between, I don't know, exercise 7 and exercise 8. So you can use all the git machinery to get all the informations for that project. And also on the website I always write which tag you should check out for a given exercise, right? So that's basically is what I wanted to show you about this one. Okay, and all in all, with that we are basically at the end of everything which I wanted to show you. And maybe just some conclusion or some further git notes at the end. Of course, as always, please read the manual. I'm definitely not able to tell you all the fine details which Git can offer you. Git is a very, very nice and very sophisticated tool, and basically it offers you plenty of possibilities, and you should maybe also make a tutorial in the some other additional tutorial if you want on the internet. Also, you should please commit regularly. So whenever your thing changed, your project changed significantly, you must commit, okay? And the commit message and the commit content should be in sync. So basically, you always should commit files changed for the same purpose, right? So basically, whenever you finish something, let's say cleaning up the project, then check it in and then implement a new feature. Whenever the new feature have been implemented, please check it in before you start with the next one, and so on and so on. And otherwise, basically here that some other we discussed already that everything is stored in a .git subdirectory. Of course, the git commands which you execute must be executed in the project directory, right? So basically, if you want to have for the solution lint solver project to make a git command, you have to be in that directory. If you go out of the directory and you make git log, then Git will not find any directories with a .git. So whenever you want to execute a git command, please execute in a directory which is either your project directory or a subdirectory of your project. And last but not least, maybe about this let's go back to lint solver, about this awful hash marks or hash values. So that's the last thing about this one here, which are appearing. Those are universal identifiers. So basically every of them occurs only once in your project tree. So basically everyone assigns or gives the state of your project at a given time. So if you say I want to have this commit, it means it will get you exactly that state of your project which it had exactly at that date, at that point when you checked it. Okay, With that, I think we can finish the Git part. Be sure that you are mastering Git. We will use it in every lesson, and I hope if you start to develop software tools, it will be your daily workhorse, basically, and you will see that it's not just programming projects, but even if you are writing a dissertation in LaTeX, for example, Git is a very nice tool to keep track of the changes you do at different stages, or if many people are working on the same text document. So there are a lot of different scenarios. Whenever you are working with text-based documents, Git is a very, very nice tool to handle the revision history. So make sure that you master Git, and I will also try my best to help you in that. Thanks a lot for your attention, and I hope to see you in the next session. Take care. Bye-bye.